we're recording now. Yeah, no question is too small. Okay, are we okay with all of these? Notice that, oh, too bad Jack left because he was asking me a little bit about this. Notice that sometimes they give you just the generic f of x, and that means they're just testing the concept, right? If it's an f of x form, if it's given to you in f of x form, generic form, you have to use the f in the answer, right? But then this one, they actually gave you the specific equation. So you know exactly, I don't know what this graph looks like. There's no way for me to know. Well, hi Jack, I was just mentioning your name because the first two questions on homework are kind of what we were talking about. So if they give you the f in the question, I don't know, what does this graph look like? I have no clue. The only thing I know about it is that it's a function, because there's the f there, right? So I know it passes the vertical line test. So if it says translated 2 units to the right, all I could do is this. X, is it minus or plus? Remember f, the x always kind of screws you up. It always plays tricks on it, right? Think about this, because you know what that represents? That represents the intercept on the line. So what value of x zeroes this out? Would zero the fraction out? 2, right? 2 minus 2 is 0. Okay, so this one though, this time they did not give me the generic. I know what the function looks like, right, Jack? So this is an actual function. This is a quadratic, so it's parabola, vertex 0, 1. So parabola opening up is translated 1 unit right, 2 down. Here, I don't use the f. I actually know the function. So 1 unit to the right, it's x minus 1 all squared. 2 down, minus 2. Okay, see the difference? If they give you the f, you have to use it, because they're just testing the concept. Here, they're actually want the whole function. All right, I'm not going to go through every question. I just wanted to talk about those, unless there are some issues. No? How many people had time to look over notes? Yeah? So these are, these are notes. Sometimes it's a very technical book, because Fortius Pre-Cal's technical. Kind of gets you set up for next year. If you go to post-secondary, you can have a lot of technical textbooks and manuals to look through. So it talks about here, this first page. Yes?
Why is it x, y equals to x minus 1? Because you know how, like,
where are we? On the homework? Oh, okay. Sorry. Hang on. Yes?
Is it like, because remember it's y equals to x squared plus 1? So
Oh, sorry. Yes, thanks. Oh, Evie, thank you so much. This was a trick question. Yeah, though it was already sitting at 1. If it goes 2 down, 1 subtract 2 is is minus 1, right? Correct? Thank you. Thank you. I didn't even read carefully. Thanks, Evie. You corrected me. Okay, everyone good with that? Because it gave me a plus 1 here. Okay, so here, it's very technical to get through. If you kind of just looked at it, it sort of made sense, that's good. They actually gave us specific functions that we were looking at, right? The absolute value function, they actually gave the absolute value function to work with. So it wasn't one of those F forms. There's not much, it just talks about words again, and it tells you, again, if you have a half x, that's actually going to make the graph wider, right? All right, that's it. And then we go, they summarize this. It's a nice summary. I think on the, I thought there was an overall summary at the end anyway. So every time there's like an open box, this talks about the A values again, and it's duplicating what we talk about in class, right? So duplication is nice for when you're learning something. So this is the effects of the A value. That's the vertical. Notice remember that f of x is another name. You can think of it for y. So the A is being multiplied on the y, right? That tells you it's a vertical change. And then on the next page, we talk about the horizontal compressions or expansions. And notice horizontal isn't acting on the x value, so the b is included in the x. And here's your kind of summary here. And again, your examples workbook that we worked through in class also summarizes these. And then they actually gave you some pictures, which is nice. The graphs aren't the best, but better than nothing, I suppose. Sometimes it's hard to see if graphs are quite, these graphs are small and there's not the scales aren't really given to you nicely, so sometimes it's hard to see. You can see it though, right? This is the original cubic. So look what happens if I have a 6x cubed, for example. It makes the graph narrower, or 1 over 6 makes the graph wider. Let's take a look here because it's going to make a difference for homework though. It says, without graphing, describe the compression or expansion. Okay, so this was the original graph. Here's my original graph. X squared minus 3, it's a quadratic. So this is what they did. They had a multiplier over root 2. That means every x value is multiplied by 1 over root 2. It's kind of a weird number, right? But what that has effect is 1 over root 2, that's this is a little deceiving, right? I guess I should pull a calculator out, which I don't have on me. What is root 2 is 1.4 something, right? So it's actually a number larger than 1, 1.414. So a number larger than 1 compresses the graph, right? If I have a fraction, a small number, a number between 0 and 1 in front of the x, it works as an expansion. Here, a number greater than 1, it's going to be a compression again by 1 over 2, okay? So everyone's fine with this top line, right? What they did down here, they just simplified. Root 2 squared is just the number 2, right? This is how you could leave it for me in answers, but 1/3 squared gives you the 1/9. So then when you're given the equation without brackets, they've just simplified it. That happens a little bit in today's assignment, right? And I can go over those with you. It's not necessary to go to the simplified version in this class, but I'm just telling you that the book uses a simplified form, okay? And then there's going to be some combining that we're going to do, so we can combine A's and B's. When you have combined transformations, we're going to see this today, if I have an A and a B value, it doesn't matter the order you do them in. It's multiplication. I'm multiplying the A by the Y value, the B by the X value, or the 1 over B. Multiplication, the order doesn't matter. Okay? And that's it, I think. Right? Let's just quickly talk about, I'm going to talk more about these today. Let's quickly talk about example 4. I want to talk about this word zeros. What does the word zeros mean to you? What are zeros? Yeah, another name for zeros are, another name for zeros are x-intercepts. So this book uses the word zeros. Assignments and tests will use the word zeros or x-intercepts. I think we're more familiar with the term x-intercepts, and that's more meaningful for us. But the word zero came out because that's where the graph, so this is the original graph, right? The original graph is the paler one, okay? This is my original graph, and it probably has arrowheads. So this is my f of x. So the reason they're called zeros is that's where the x values are equal, or these are my x-intercepts. That's where the function itself has a value of 0. All of these spots are where y equals 0. That's what zeros are. So this is my original graph, and this is the transformed graph. Okay, what kind of transformation was done with this -2? Is that an A or a B value? A equals -2. So what does A affect? What kind of effect does A have? What will we call that? This graph that represents a vertical stretch, right? By, I'm going to say a factor of, I'm going to say -2. Okay? Because the negative represents reflection over the x-axis. Okay, so if the x-intercepts of this graph, the x-intercepts of y equals f of x are, okay, it's hard to see on this graph because no numbers are given, so I'm counting notches, but they actually gave them to me up here anyway. -2, 1, 3. -2, 1, and 3. Those are the x-intercepts, right? If A is -2, it only affects the y value, correct? The x-intercepts aren't affected by an A value, correct? The x-intercepts are not affected or changed by a vertical stretch. So that's all that this example is pointing out to you. It said the original graph has x-intercepts of -2, 1, 3. Here's the transformation. State the new x-intercepts. Kind of a trick question. They're not changed at all. They wouldn't be changed if it was just a vertical stretch. Now, however, for this example, same original graph. It's the same graph given to us. It's kind of like when we did our changing our domains and ranges yesterday. This is y equals f of x. This represents y equals f of 1/3 x. What does that 1/3 do? Do you remember what that does? B equals 1/3. If B is a small number, that means there's a horizontal stretch by a factor of 3, right? So every x value is multiplied by 3. So if every x value is multiplied by 3, will the x-intercepts change? Well, here are my old x-intercepts. My old x-intercepts are -2, 1, 3. Every one of these guys is going to be multiplied by 3, right? So my new x-intercepts are, okay, -2 times 3 equals -6. 1 times 3 equals 3. And 3 times 3 equals 9. Okay, so these are my new x-intercepts. The x-intercepts will for sure change with the b value, right? Because b is multiplying every x. So let's see if that's what happened. 1, 2, 3, 4, 5, 6. Yep. 1, 2, 3. Yep, that's my new x-intercept here. And then 4, 5, 6, 7, 8, 9. Right? That's all they're showing. Okay, so hopefully you read that. When I assign reading, I'm hoping you read. It just gets you a little familiar with the content that we're going to discuss in deeper detail during class. So even if you read it through and it doesn't make 100% sense, something will have sunk in. So now let's just finish up these examples, these 2 examples, and I'm going to give you a bit of time. Actually, there's quite a few examples. I'm going to give you a bit of time to work on the assignment. We're going to finish off stretches and compressions, so we'll have a little more today. So I left off on page 11. Oops, I'll erase that for now. We're starting on page 12. And there's going to be lots of time to ask questions today because I'm going to give you some work time and I'll be buzzing around, and if you have any other questions, let me know. So determine the coordinates of image points after a stretch or a compression. All right. So once again, what we're using is, these are what all we're concentrating on today. A, F, B, X, right? I'm just using it in a contextual approach. So I'm not going to bring shifts into it yet. We'll do that tomorrow. We're just concentrating on A and B value, even though we know the H and the K. We did those the last couple of days. So remember, A, vertical change, B, horizontal. So let's take a look here. The point A lies on the graph of y equals x squared. Okay, we actually know the function this time. What are the coordinates of its image on the graph of negative 2x squared? Okay. Is that an A or a B value? B equals negative 2. Okay? This represents a horizontal compression, right? If B is greater than 1 by a factor of 1 over 2. Okay? You always multiply the x by the reciprocal of b, right? All right, is there any change on the y? No change on the y value. Why is there no change on the y value? Because there's no number outside the brackets, right? There's no number represented there. Okay, so the point A, I'm going to multiply negative 1, okay, the x value, I guess, the new x value, negative 1 times negative 1/2 is positive 1/2. Okay. Coordinates of A are, or A primed are, positive 1/2, positive 9. That's it. You guys might be the quietest. If you're not the quietest class, you're in the running for the quietest class. You just really tired or bored? Both? Okay, the next one. The point B, this is weird. 0.5 comma 9 lies on the graph of y equals root x. What are the coordinates of its image B primed on the graph of y equals root 3x? Okay, again, is that an A or a B value? It's another B value, right? B equals, okay, this is what they gave me to work with. They gave me the root, so B is just 3. Agreed? So I'm gonna, again, this represents, it's a horizontal compression by factor of 1 over 3. Now the reason I'm using a fraction here, this is a kind of a weird way. I think I'm going to change. Let's change 0.5 to a fraction so we can work with it easier, because that's a weird number. What's 0.5 in fraction form? Half, right? So B is 1/2 comma 9. B primed will be, okay, I'm going to take this 1/2, multiply by 1/3, and I'm going to get 1/6, right? This is my new x value. Again, if you're rusty on your fractions, you're going to have to do a little bit of brush up. So my new coordinates will be 1/6, no change on the y again, right? Agreed? I'll add in brackets, no change on y value. Because there's no a, right? Okay, let's take a look at example 7. Given this graph, this is the graph they gave us to work with, so they're calling it h of x. Sketch this new graph. All right, this time I've got a little bit of a combined transformation because I've got an a and a b value, so there's going to be a equals -1/2, b equals 2. Agreed? I'm going to give you a minute. I want you to write out in words or think in your head if you can describe the two transformations that would be involved in an a value of -2 and a b of 2. I mean descriptive words. So take a minute and see if you can do that. Okay, can someone describe what an a value of -1/2 will do to my graph? Okay, vertical compression by a factor of 1/2. I'm going to actually do, I'm going to say -1/2 because that's what we're going to multiply by. But that also represents a reflection over which axis? All the y's become their opposite, right? X-axis, right? I think this is too dark. I'm going to go back to pencil. What does the B represent? Horizontal by factor of, because it's going to get smaller, right? 1/2. Okay, so this is where I have to pick a couple of, I'm going to do my mapping approach, so I'm going to pick a couple of critical points. This is kind of a tough one. I'm just looking for points that kind of fit, that I can read the coordinates. So I'm going to pick this one, and I think this one. I like picking the dips, but to be honest, this one's kind of hard to read, isn't it? So I'm actually going to pick this one instead of the dip. And I think we'll do, I don't know, one more, this one. Just because this is actually a polynomial function. It's a type of cubic function. So I'm going to pick 4 points. And so what will they be? -3, 6. -2, 15. 0, 3. And 1, 6. Now, you could pick a whole, you could pick 4 different points. I think I'd have to have at least 4 points for cubic because of the 2 bends. If it was just a linear function, I could get by with 2 points, right, to reproducing a line. But for polynomial, I have to get at least 4 points going so I can get the shape. All right, so if I know that when I say by a factor of -1/2, that's what my y, that's a acts on the y. So I'm going to multiply every y value by -1/2, and I'm going to multiply every x value by 1/2. So that's the math that I have to do. When I do mapping, it just shows me the mathematics involved. All right, so again, -3 times 1/2, I could just call that -3/2. It's my new x value. I think I'm going to do all the x's first like I usually do. So I'm just going to cover up the y's. I'm just going to do all the x's. Negative 2 times a half, negative 1. 0 times anything is 0. 1 times a half is a half. I like doing all my, like I say, all my x's first because you kind of get in the groove. Now I'm just going to work on my y values. 6 times negative a half is what? 15 times negative a half, I'm just going to call that negative 15 halves. Or negative 7 and a half, yeah. Okay, 3, negative 3 halves again. That's like negative 1 and a half, right? Or negative 1 and a half. And 6 times negative a half, well, we saw that up here already. It was negative 3. Okay? I'm going to plot these new points, and that's how I'm going to connect my dots, right? However I plot them, that's the order that I connect my dots. So negative 1 and a half, negative 3. These are kind of weird little graphs. So that's my first plot. I'm going to remember that. Negative 1, negative 7 and a half, and this doesn't, this is too short, right? Negative 6, negative 7, negative 8. This is not that nice. Negative 1 comma negative 7 and a half, so it's about right here. 0, negative 1 and a half. And 1/2, negative 3. Okay. So this is my order. 1, 2, 3, 4. And I have to, even with my dots, it's kind of hard, right? So I'm just trying to duplicate my shape. Actually, hold on a sec. I'm not going to do that yet. It's going to be 1, 2, 3, and that's it, right? So I started out the wrong way. So this is all you got, and you can see your tails are pointing in the opposite directions, right? So this was my first point, my second point, my third point, my fourth. So this is the graph of y equals negative 1/2 h 2x. So what did I expect to happen? It should have been squished a little bit. This looks a little odd here, doesn't it? My little, it should look more like this. Okay. My graph should have been squished. It does look more squished, doesn't it? Look at this distance compared to this distance. So it's squished horizontally, it's vertically compressed, and it does look vertically compressed, and it's also flipped. Agreed? The tails are pointing in the opposite direction. Yeah? Any questions?
I'm sorry. Oh, the graphing. The first step.
Mhm.
Is it 2.5? I thought it should be 1.5, right?
Yeah.
Where?
The first point.
This point?
Yeah.
Did I screw it up? Let's see. Okay, let's see. Where is it? Negative 1.5, negative 3. So negative, oh yeah, 1.5. Negative 1.5, negative 3. Oh, it should be here, right? Thank you. That looked a little odd. Thank you. Like that? That looks better, right? It looks much more squishy. Thank you. Is it Carlos?
Carl.
Carl? Thanks, Carl. So you guys don't be scared to jump up. I make mistakes, not all the time, but I do make mistakes. Hope I don't make them all the time. Okay, that looks better. That looks much more squished, doesn't it? More squished, squished, flipped. That looks much better. Better representation. I find that grid hard to look at. Okay? All right, let's take, here's some, whoops, I already had the answer. we're going to leave graphing for a moment. This is just another conceptual. Do you really understand what's going on? The point A lies on the graph of y equals x cubed, so we're actually given a graph. What are the coordinates of this on the graph of negative 0.75? Okay, you don't have always kind of think I don't have a calculator with me, so it's really hard to use that. So let's change this form to fraction again. Y equals negative, what's 0.75 as a fraction? 3/4. Let's change that to 3/4 x cubed. Okay. So here's your image point, or here's your original point. Here's your change. Is that an A or a B value? B. So B equals 3/4. Is there an A value here?
Yes, ma'am.
Yeah. Who said that? Aminette? So if there's anything outside the brackets, even if it's just a floating negative sign, that qualifies as an A value. There's really an invisible 1 here, isn't there, Aminette?
Yeah.
So there is a change on A. A is negative 1. Okay. B is 3/4. A is negative 1. Give me the coordinates of the image point, of the new point. See if you can figure that out. Okay, anyone want to be brave? It might involve fractions, so just leave your answer in. If there's a fractional answer, just leave your answer as a fraction. Anyone want to be brave? Negative 4 and 12. Okay, so I just did my mapping approach here. I'll show you my work too, right? So if my x, y, I only have one critical point for negative 9. So what would I multiply every x value by? 4/3 times x, and I'd have to multiply every y by negative 1, right? So negative 1y or negative y. Agreed? So if I multiply 4 times 4/3, I would get 16/3. And the opposite of negative 9 times negative 1 is just positive 9. So I would say the coordinates of A primed are 16/3, comma 9. Now I would just leave it as 16/3. If you're not told to change it out of fraction form, don't. Does anyone agree with me? No one agrees with me?
So whenever you're doing the B values,
Yeah. Now, there's different ways to describe it. That's kind of an interesting thing. Like, I think your book said divide by B, right? You can divide by B. You can. So let's say I had y equals, I don't know. I'll put a 2 out of here. 2 times 3x. Okay. So you always, I tell you, you always multiply by the reciprocal, right? So let's say I had a point of, I don't know, 6, 10, okay? So the mapping is going to be, I tell you guys to multiply your x values by x would be multiplied by 1/3, agreed? And y would be multiplied by 2, agreed? So when I multiply something by 1/3, 6 times 1/3, that's going to give me 6/3 or 2, right? You could also say, well, just divide by your b values. Dividing by a b value, 6 divided by 3 also gives you 2. Dividing by b and multiplying by its reciprocal gives you the same thing, gives you the same answer, right? If if b equals 2, okay, like that, or y equals 2x, and my point value is, let's say my critical point is 4, 7, for example, and I don't know, 26, 0, and all I have is a 2x, I'm telling you guys multiply by the reciprocal. 4 times 1/2 is 2. 4 divided by 2 is 2. 26 divided by 2 is 13. 26 times 1/2 is 13. Multiply by the reciprocal is the same as dividing. The only reason I tell you guys multiply by the reciprocal is it's easier if you have fractions like 4/3 because you can just flip them. Telling someone to divide by a fraction, to me, anytime dividing is involved, dividing is harder than multiplying. That's why I tell you guys multiply by the reciprocal. It's easier than me telling you divide, because then dividing throws people's heads into a loop sometimes when you're working with fractions. So I stick to multiply because multiply is easier, so I'm just going to say multiply by the reciprocal. Right? Okay. So let's do this one. Here's my point. Here's my critical point. My critical point, they just gave me one, -1/2 times 6. And here's the graph. They actually gave me a graph 1/x. So 1/x is the actual graph. Here are the changes to the actual graph. I see an a value of 2 and a b value of -5. That's all I see, agreed? The 1/x was the original function that has no bearing on an a or b value. So my y gets multiplied by 2, that's easy. My x gets multiplied by -1/5, right? Okay, so -1/2 times -1/5 is positive 1/10, and 2 times 6 is 12. Everyone remembers how to work with fractions, right? How to multiply fractions? Just multiply the tops, multiply the bottoms.
Maybe didn't.
No? Let's do a quick...
That doesn't sound very hard.
No, multiplying fractions is super easy. Adding and subtracting fractions is hard, right? So when you have a fraction, you're multiplying by another fraction. Just multiply the numerators, multiply the denominators, that's it. Sometimes you can simplify if you get lots of common factors, but in grade 12, the rules are relaxed for you all, and you don't have to simplify fractions, even in your final answers. It just makes them easier to work with sometimes, but you don't have to simplify fractions. And there's lots of fraction work coming up in our trig units. So if you're a little rusty on fractions, you might want to come talk to me, and I can maybe direct you to some practice. Okay, let's do the last two questions. They're a little tricky in a way, maybe. But we'll see. The graph of g of x is the image of f of x. So f has been transformed to g. The original one is the solid, the transformed one is the dotted. Corresponding points are labeled. Notice these are the original points, a and b. The transformed graphs are a prime, b primed. Anytime you're asked a question like this, it says write an equation of the image graph in terms of f. Anytime you're asked to write an equation of a given graph, you must be given some points to work with. I had to give you A and B, how far away original A and B were, so you can compare that to the A prime, B prime. Does that make sense? I can't just give you graphs without any points identified. If I did, that would be an error on my part, because what we're doing is you have to kind of count, well, how far were the original A and B together, so that you can compare them to how far they are now. So what we're doing is we're just seeing if there has been a transformation. Visually, does it look like the solid graph for sure looks different than the dotted, agreed? What does it look like happened here? It looks like it's been, yeah, compressed somehow, right? I guess sometimes graphs, the simple graphs, like an absolute value or parabola, you could actually describe this two different ways. Would you agree with me? I could say it's compressed, or I could say it's been stretched, right? You can kind of go two ways on absolute values and quadratics. But they gave us points to work with, so let's see. Let's see if there's been any vertical change, okay? So I'm just going to shoot. Let's check for a vertical change. It looks like it's been stretched, but I'm not sure, maybe not. So what is the distance from A, the vertical distance from A to B? From A to B, what's the vertical distance? I think it's just 1 unit, isn't it? Like if A is sitting at 1 and I move up to 2, okay, is 1 unit. Okay, let's check from A prime to B primed. Here's where A primed is on the vertical axis, and B primed is at 6, right? From A primed to B primed, the vertical distance is, well, it's from 3 to 6, right? I guess the vertical distance has been doubled. Agreed? From A to B was just a distance of 1, right? From A to B primed, or like 1 times 2 is 2, 3 times 2 is 6, right? It's been doubled. This means A equals 2. Vertical stretch of 2. Yeah? I'll say more words. The vertical distance is doubled. Yeah? Okay, let's check sideways. Let's do horizontal changes. Okay, how about from A to B? 1, 2, 3, a distance of 3 units, right? From A prime to B primed, 1, 2, 3 units. Was there any horizontal change? No. From A to B, a distance of 3 units. From A prime to B primed, a distance of 3 units. No horizontal stretch or compression. Okay? So this means B is just 1. There's no change at all. So the new equation all we had was an A value of 2. So So it says, write an equation of the image graph in terms of the function f. So y equals 2f of x. It just means if I start with f of x, all that happened was I had an a value of 1, or a value of 2, my b value just remains 1, and I don't write 1's in. And that's it. That's the only change on this graph. So there was no horizontal stretching or compression at all. It's just that the graph was stretched by a factor of 2. EB? No? This is the most abstract unit we ever do. Transformations. We'll just power through this one. And Eduardo? Question?
How did you determine the width?
I just counted. So the only thing I can do is, okay, so what I'm doing, big picture is, I'm just comparing any changes. Yeah.
Isn't it stretched by a factor of 3?
1. Okay, so wait. What did I do here? 1 unit, right? From 1 to 2, and then 3 times 1, 2, 3. Okay, let's do this. I'm going to try this. I'm going to take my critical point. What is it? 5 comma 1. And 2 comma 2. Let's see what it transformed. Did I make another error? So let's say I'm no change on the x, right? And I said it doubled, right? So 2y. Let's see what I get. So no change on the x, and that should be a 2, and that should be a 4, right? 5 comma 2. No, and it's 3. It is 3, right? Oh, you guys. I don't know what I'm doing here. 3 and 6. It is tripled. Ay, ay, ay. Is that what you're confused about, Eduardo?
Yeah,
I gotta take a break. We gotta stop for a break. Tripled. Vertical stretch by 3. I'm not going to do that lame teacher thing and say, oh, I was just testing you guys, because I wasn't. I'm getting all... Okay, so let's see why. Let me go back and try and, or maybe we'll get it's Neville, right? We'll get Neville to come up and explain it to you. Okay, so let's count again. So here, from here to here, vertical distance of 1, right? What am I doing? 1, 2. Oh, you know what? Okay, you know what? Go take a break, guys. Take a break. It's time to break, and I got to stop, and I'm going to redo this. These numbers are fine, but I'm going to re-explain it after the break. Go take a break. We got one more example to do, and then if you're done, you can even start. If you're not going to go for a break, I'm going to assign lesson 1.4, I think. Yeah, I'm going to assign 1.4 in the book, so you can start working on that. And I also have a little assignment if you want to just hand it in to me for... and I'll have it marked to you just so you can assess your skills so far. Everyone's got course outline, right? You're already sitting close. Do you have glasses? If not, you can sit closer. Try bringing your glasses down. See if it makes a difference. And if not, maybe I'll make it the black or darker pen. Is that better? Okay. Monday there's no school. Okay, Monday there's no classes. No classes on the 16th. Okay. No classes on the 16th. Are you gonna do tomorrow? No classes. Okay, starting tomorrow. I'm gonna go on to. I'm gonna finish up the unit. Probably finish the chapters. I'm thinking probably test Wednesday. Can you hop on the blog though and look? Did I, if I link any news or anything, I'll link it to the blog too. I work today.
Okay, yeah, it's my best friend getting it down, so. I just or something like that. I'm not sure. That entire
No, you don't have to do the class. Did you get Jack, you know what I was going to say to you, Jack? That's working. So if we do this. But then, oh, your question was, would it work if we just use this one?
No, I graduated from
Why equals what?
I graduated from this week.
So what x is 2?
Because I'm going to go on like
Y equals f.
so to get it
Y equals f at negative 1. That's the bulge odds. Because you kind of did that in it's function notation. So when it says find f at negative 1, f at negative 1. So this is f at negative 1. Find f at negative 1 is. Let's say 0.25. So y equals 0.25. So when x is 2, it should be 4 and that's 4.
So you get.
So you're taking a table of values, yeah.
Now this one is just to the right.
Now, all the points that we gave you should actually lie on this point.
Yeah, no. The y is
Doesn't. That should change.
the y is a negative 1. So we go down this y is 1 here.
That's wrong. We should have just kept this as f of x or something. You know what I mean? I'm gonna change that for next time.
Alright, I'm gonna
Negative.
Okay, you guys are doing really good. Okay,
Start on this side. I think possibly Wednesday you said
Next one.
really all less to do. So, like you have said, Monday goes to school, so we'll finish off. We have 2 more days this week. Then we'll do some review on Tuesday. I'll probably give you some for the whole weekend and you guys will write the test Wednesday.
One, we lift up.
Then you're done. Yeah. If you want, just come grab this and yeah, you can have them when you're done. Shifting is super easy, right? That's what I think you need some kind of procedure, because otherwise it gets too confusing, right?
One charge is equal. Okay, this is.
Yeah, if you want, you can grab, please work on. I'll do that last example a little later, but you can work on exercise
Yeah.
1.4.
This is.
Guess I should